Good morning, everyone. Some basic concepts in chemistry. In that we discuss mole concept, all those things, and atomic weights. Next, after we start structure of atom. Structure of atom. So, in that case, we completed what is matter, Dalton's atomic model, who discovered electron subatomic particles. Smallest, according to Dalton, the smallest indivisible particle is atom. But after that, many scientists came, told that yes, atom is not the smallest particle. In that also, smallest particles are present. Those are what electrons, protons, neutrons. So J.J. Thomson discovered the electrons. Goldstein discovered the protons. James Chadwick discovered the neutrons. Here, we know the charge of electron, proton, neutron. These are the subatomic particles. You know the charge, mass of these particles. We call as subatomic particles. Subatomic particles. So minute particles. So electrons discovered by J.J. Thomson. Charge is here. Electron is discovered by J.J. Thomson. Scientist name is J.J. Thomson. Charge of electron is mass minus, these are what electrons are negatively charged particles, minus 1.602 into 10 to the power minus 19 coulombs, mass 9.11 into 10 to the power minus 28 grams. So protons discovered by Goldstein. So charge is, these are positively charged particles. So C means coulombs, the charge unit. Mass of proton is 1.672 into 10 to the power of minus 24 grams. Neutron, James Chadwick. So here 0. Mass is equals to proton, nearly equals to proton. Mass of neutron. Electron discovered by J.J. Thomson is a charge, negatively charged particle. Mass. Proton discovered by L. Goldstein. The positively charged particles, mass of the proton is 0. Neutrons discovered by James Chadwick. The neutron. So here, mass of the neutron is 1.614 into mass of the neutron. Next. Nucleus is discovered by J.J. Rutherford. Alpha rays capping experiment completed in the answer. In nucleus, protons and neutrons are present. So that one completed. And then atomic number. Atomic number is the number of protons or electrons present in an atom. So I'm going to take helium. Helium atomic number is 2. That means helium atomic number is 2. That means in this helium, 2 protons, 2 electrons are present. This is the meaning of atomic number. Atomic number means the number of protons or electrons present in an atom. So here example is like the helium atomic number is 2. That means in helium atom, 2 protons, 2 electrons are present. Next, mass number. It is written A. Mass number is the sum of protons and neutrons. Protons and neutrons present in the atom. So here mass number is equal to number of protons less number of neutrons. So here proton number plus neutron number is equal to mass number. Here proton number nothing but atomic number. So just this N A. Then N is equal to A minus A. Mass number, the sum of the protons and neutrons present in an atom is called mass number. Mass number is equal to number of protons plus number of neutrons. Mass number is equal to protons plus neutrons. Proton number we know as atomic number. So then neutron number is equal to A minus A. So now we complete last class. Next, isotopes, isobars, isotopes. What are isotopes? Isotopes means the atoms of same element is having same atomic number and different mass number. It's called as isotopes. Examples: H1. See here, hydrogen is 2 isotopes for the same atomic number. You know already we represent element subscript Z atomic number, superscript mass number. Here one is the atomic number, here one is the mass number. So observe here, in both cases, both atoms, atomic number is same but mass number is different. We call it isotopes. So now we come. Yes, isobars. The atoms, different elements, having same mass number but different atomic number, called as isobars. The atoms of different elements having same mass number but different atomic number we call as isobars. Examples: argon 1840, calcium 2040. So here observe here argon and calcium possess same mass number but different atomic numbers. We call as isobars. Isotopes. The atoms of different elements having different atomic number and mass number, but containing same number of neutrons. It's called as isotopes. Called as same number of neutrons. Called as isotopes. The atoms of different elements is having different atomic number and mass number, different mass number, but same number of neutrons called as isotopes. For example, sodium, sodium and magnesium. 11, 23, get 12, 24. So already we know neutron number is equal to A minus Z. Mass number minus atomic number. It is 23 for sodium. 23 minus 11, we get 12. Same thing you apply for magnesium also. Is equal to A minus Z. 24 minus 12, we get 12. So in these four cases, sodium possesses different atomic number, different mass number, but possesses same neutron number. We call as isotopes. Then all of you take this table. Element, symbol, atomic number, Z, mass number, A, and number of protons, number of electrons, number of neutrons. Protons number, electrons number, neutron number. All of you take this table. First column element, symbol, atomic number, mass number, protons, electrons, neutrons. First element is hydrogen. Symbol hydrogen is H. Atomic number is 1. Mass number 1. Number of protons. Atomic number 1 is here. Hydrogen 1 proton, 1 electron. Here mass number is equal to 1. Here neutrons 0. A minus Z. So A is 1. Z is 1. So here we get 1 minus 1, 0. Number of protons, electrons, neutrons. Element hydrogen. Symbol is H. Mass atomic number 1. Mass number 1. The neutron number is equal to A minus Z. So A is 1, Z is 1. So a neutron 0, proton. The atomic number nothing but the number of protons or electrons present in an atom. So 1, 1. Next element, helium. This element is helium. Symbol is He. Atomic number is 2. Mass number is 4. 4. Number of protons 2. Number of electrons 2. Because atomic number 2, so number of protons 2, electrons 2. Then neutrons mass number minus atomic number. Here mass number is 4, atomic number 2. So 4 minus 2 you get. So helium symbol is He, atomic number 2, mass number 4, number of protons 2, atomic number 2. Sorry, number of protons 2, electrons 2. Neutrons mass number minus atomic number, mass number is 4, atomic number 2. Okay. It's lithium. Symbol is Li. 3. Mass number is 7. Number of protons, here atomic number 3 means number of protons 3, number of electrons 3. Then take mass number is 7, atomic number is 3. We get how many neutrons? Which all of you take this table? Hydrogen. Atomic number 1, mass number 1, proton, proton. Helium, symbol 4, number of protons 2, number of electrons 2, number of neutrons. Lithium, atomic number 3, mass number 7, number of protons 3, number of electrons 3, neutrons 2. Next element, beryllium. B is the symbol. Atomic number 4, mass number 9. So number of protons 4, atomic number is 4. So number of protons 4, electrons 4. Neutrons 9 minus 4 you get 5. 5 neutrons are present in beryllium nucleus. Boron. Symbol is B. Atomic number 5, mass number 11. Number of protons, atomic number is 5, so number of protons 5, number of neutrons 5. Number of neutrons 11 minus 5, you get 6. Next, carbon. Symbol C. Atomic number 6, Mass number 12, 6 protons, 6 electrons, 6 neutrons. Beryllium, boron, carbon. Carbon, 6, 6, mass number 12, number of protons 6, number of electrons 6, number of neutrons 6. Nitrogen, next element, nitrogen, symbol nitrogen N, 7, mass number 14, number of protons, atomic number 7, so 7 protons, 7 electrons, 7 neutrons. 14 minus 7, we get 7. 7 protons, 7 electrons, 7 neutrons. Oxygen, symbol is O, 8, 16, here number of protons is 8, number of electrons 8, 16 minus 8, we get number of electrons 8. These are all the properties. Next element, fluorine. symbol F, atomic number 9, mass number 19, number of protons 9, number of electrons 9. So mass number 19 minus 9, you get 10. Neutron number is 10. Neon, this element is neon. Symbol is Ni. Atomic number 10, mass number 20, number of protons 10, number of electrons 10, number of protons also 20 minus 10. This copy is fluorine neon. Fluorine atomic number 9, mass number 90. So atomic number 9, so number of protons 9, electrons 9. Neutron number, mass number minus atomic number, 19 minus 9, 10. Yeah, atomic number 10, mass number 20. So atomic number 10, so proton number is 10, electrons are 10. Mass number is 20 minus 10, 10. Next. Sodium. Sodium. Symbol is Na. Atomic number 11. Mass number 23. Number of protons 11. Number of electrons 11. Number of neutrons 23 minus 11 you get. Magnesium. Symbol is Mg. Atomic number 12, mass number 24, number of protons 12, number of electrons 12, number of neutrons 24 minus 12. Next element, aluminium. 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 Symbol is A. Atomic number 13, mass number 27. Number of protons, atomic number 13, so number of protons 13, electrons 13. 27 minus 14, 13, you get 14 protons. Next silicon. Si is the symbol. Atomic number 14, mass number 28, number of protons 14, electrons 14, number of protons. Aluminium symbol is Al, atomic number 13, mass number 27, number of protons 30, electrons also 13, number of neutrons 14. Silicon, atomic number 14, mass number 28, number of protons 14, number of electrons 14. So 28 minus 14, mass number minus atomic number we get neutron number. Homework is, please all of you write up to 20 elements, atomic number, mass number, number of protons, electrons, neutrons. Up to 20 elements. Here I gave up to 14, that's 15, 16, 17, 18, 19, 20. You have to write atomic number, mass number, proton, number of protons, number of electrons, and neutrons. Make it stable up to 20 elements. Make it stable up to 20 elements. Next, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, urate. Atomic number, mass number, number of protons, number of electrons, and number of neutrons. This class we see remaining elements. Homework is you read this table and make it stable up to 20 elements. This is your homework. So this class is starting in 5 minutes.
Good morning. Yeah. In yesterday's session, we have seen the six trigonometric ratios, their values from 0 to 90, the behavior from 0 to 90. And apart from that, we have we have just verified a few results like sine 2a is same as 2 sine a cos a. Next, cos 2a is cos square a minus sine square a, or 2 cos square a minus 1, or 1 minus 2 sine square a, isn't it? And tan 2a is 2 tan a by 1 minus tan square a. Few results we have verified using what do you say, as a problematic form, taking a and b values. Now, today again we will come across a few more results related to angles of the type a plus b, or a minus b, or a plus b plus c. Angles of this type, where a plus b, a minus b, or a plus b plus c. These are called as compound angles, etc. of this form, etc. of this form. We call them as compound angles. Compound angles. They are called compound angles. Okay. Now, these compound angles will find related to trigonometric ratios now. Means, what is the sine of a plus b? What is the sine of the compound angle a plus b? What is the sine of the compound angle a minus b? Okay. Similarly, what is the tan of a plus b? Tan of a minus b? Cot a plus b? Cot of a minus b? So these all will be just checking out these results today by taking values for a and b. Okay, we'll take it as a problematic form and find the compound angles. Now, we take it as a problem for today's class. The first one for today's class. If a is equals to a is equal to 60 degrees, comma b is equal to 30 degrees, find first bit sin a cos b plus cos a sin b. Sin a cos b plus cos a sin b. Okay, and we find the value of sine of a plus b. Sine of a plus b. These two results we need to find. Okay, now let's take it out. What will be the first result? Sine a cos b plus cos a sin b. Sin a cos b plus cos a sin b is equals to, substitute the values of a and b. A is 60, b is 30. B is 30. So this will be sin 60 cos 30 plus, cos a sin b. Cos a sin b is cos a value is 60, sin b sin 30. Sin 30. Okay, now this is sin 60, which is, yesterday the tabular form for the trigonometric values, their behavior from 0 to 90, we have made it as a tabular form. Now, from the tabular form, just figure out what is sin 60 is. Sin 60 is root 3 by 2, and cos 30. Cos 30 is, cos 30 is also root 3 by 2, plus cos 60 is 1 by 2 into sin 30 is 1 by 2. So this comes to root 3 into root 3, which is root 9. 3 again by 2 2 is 4 plus 1 by 4. The result comes to LCM is 4. So 3 plus 1. 4 by 4, the result is 1. So this is about the first bit. This is about the first bit. Coming to the second bit now, it is sine of a plus b. A plus b is equals to sine of, substitute the values of a and b. A is 60, b is 30. B is 30. So this comes to sine of 90, which is 1. Sine of 90, which is 1. So we come to know what do you infer from these two bits is, yeah, sine of A plus B is same as sine A cos B plus cos A sine B. So that's the result we get. We infer that. Sine of A plus B is equals to sine A cos B, sine A cos B plus cos A sine B, cos A sine B. Now, for the same values, that is A is equals to 60, B is equals to 30. Let us find what will be sine A cos B minus cos A sine B and sine of A minus B. Find sine A cos B minus cos A sine B, and the second bit sine of A minus B, sine of A minus B. Okay, for the same values A and B. Here, this is your IIT foundation. This is your IIT foundation. We are revising the concepts related to trigonometry. Trigonometry, that is what we have done in our 10th class. That is, and apart from it, we'll be taking few more concepts related to IIT. Okay, it's foundation for your IIT. Yeah, let's find out. The first bit, it is sine A cos B minus cos A sine B. Sine A cos B minus cos A sine B. A and B are same. A is 60, B is 30. So A is 60. So sine 60. B is 30. So cos 30 minus cos A sine B. Cos A is 60. Sine B is 30. This will come to sine 60 is root 3 by 2 into cos 30. Root 3 by 2 minus cos 60. 1 by 2 into sine is again 1 by 2. This is 3 by 4 minus 1 by 4, which is 2 by 4. That comes to 1 by 2. 1 by 2. So that's the value of sine A cos B minus cos A sine B. What about sine A minus B? The second bit of it, sine A minus B. Yeah, sine A minus B will be sine of A value is 60 minus B is 30. That comes to sine 30, which is 1 by 2. Both are equal again. The first bit, the result we got 1 by 2. And the second bit result we got 1 by 2. So both are equal. That is sine A cos B minus cos A sine B same as sine A minus B. That's the result what we get. Sine A minus B. The formula for the sine A minus B is sine A cos B minus cos A sine B. Just enclose this. Make a note. Yeah. Let's say similarly for tan. Okay. If A is equals to 30, B is equals to 60. A is 30, B is 60. Let's find. Then find cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B and cos A plus B. Third way, for the same values, find cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B. And the fourth way, cos of A minus B. Cos of A minus B. Let's take the first way. First way, that is cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B. Now, what are A and B values? Let's substitute that. Cos A is 30. It is cos 30. Cos B is cos 60 minus sin A sin B. Sin 30 sin 60. Cos A cos B minus sin A sin B. Okay. This is cos of 30. Cos 30 is cos 30 root 3 by 2. From the tabular form we have tabular form where we are written cos 30 is root 3 by 2. Behavior of all the 6 trigonometric ratios at tabular form noted yesterday. So cos 30 is root 3 by 2 into cos 60 is 1 by 2 minus sin 30 1 by 2 into sin 60 is root 3 by 2. This will come to root 3 by 4 minus root 3 by 4. This is 0. This is the value of cos A cos B minus sin A sin B. The second bit of it, cos of A plus B is equals to cos of, A is 30, B is 60. So it comes to cos 90, which is 0 again. Next, third bit of it, cos A cos B plus sin A sin B. Sin A sin B. Cos A is cos 30, cos B is cos 60 plus sin A sin B. Sin 30, sin B is sin 60. Sin B is sin 60. So substitute the values. Cos 30 is root 3 by 2. Cos 60 is 1 by 2 plus sin 30 into sin 60. Sin 30 is 1 by 2 into sin 60 is root 3 by 2. Okay, this comes to root 3 by 4 plus root 3 by 4, which is LCM 4. Root 3 plus root 3 is 2 root 3, which comes to again root 3 by 2. Root 3 by 2. Now this is about the third bit. Now fourth bit is cos of A minus B. Cos of A minus B, which is equals to cos of, A is 30 minus B is 60, which comes to cos of minus 30. Cos of minus 30. Now we have a result that cos of minus theta is same as cos theta. Whereas sine of minus theta, we had this in 10th class, we have learned in 10th class that sine of minus theta is minus sine theta. Whereas cos of minus theta is same as cos theta itself. Cos of minus theta is same as cos theta itself. Okay, so here cos of minus 30 is same as cos 30, because cos of minus theta is same as cos theta. Cos of minus theta is same as cos theta. So cos minus 30 is same as cos 30, and cos 30 the value is root 3 by 2. So what do we infer from these four results? What do we come to know from these four results is the first two are same. The first two are same. That is cos A cos B minus sin A sin B is equal to cos of A plus B. So we can say that cos of A plus B value is equals to cos A cos B minus sin A sin B, and the value of cos A cos B plus sin A sin B and cos A minus B both are equal. So cos of A minus B equal to cos A cos B plus sin A sin B. Make a note. Question number 3. Question number 3. So take evaluate sine 75. We will find the value of sine 75. Second bit, cos 15. Cos 15. Sine 15. And fourth bit, sine 75. Sine 75 altogether. Cos 75. Cos of 75. So we need to find. We need to evaluate these four values: sine 75, cos 15, sine 15, and cos 75. Yeah, first one is sine 75. How to find the value of sine 75? I can write this as 90 minus sine of 90 minus 15. Is it? Or if I write sine of 90 minus 15, 90 minus 15 I am writing. Then I use sine of A minus B. Sine of A minus B. Then sine 90 cos 15. But do I know what is cos 15? No. So you write this as 75 as 30 plus 45. 30 plus 45. Okay, now it is in the form of sine of a plus b. Already we have derived the result. What is that? Sine of a plus b is equals to sine a
cos B cos A sin B.
yeah sine a cos b plus cos a sin b. Sine a cos b plus cos a sin b. So I can find the value of it. A value is 30, A is 30, and B is 45. B is 45. If I substitute back sine of A plus B, 30 plus 45 is equals to sine A, that is sine 30, cos B, cos 45, plus cos A, cos 30, into sine B, sine 45. Sine A cos B plus cos A sine B. Now this will come to sine 30, which is 1 by 2. Cos 45 is 1 by root 2. Cos 30 is root 3 by 2 into sine 45 is 1 by root 2. So this will come to 1 by 2 root 2 plus root 3 by 2 root 2. So the result LCM is 2 root 2. That is 1 plus root 3 or root 3 plus 1. Either root 3 plus 1 by 2 root 2. That's the value of sine 75. Now, second bit is cos 15. Cos of 15. Yeah. I can write this 15 as, how to write this 15? 15 can be written as
45 minus 30.
45 minus 30. Right, exactly. You can write as 45 minus 30. Now it is cos A minus B form. Already just now we proved it. What is cos A minus B?
Cos A cos
We are saying in one of the problems. Yes, cos A minus B is cos A cos B.
plus sin A sin B.
Yeah, cos A cos B plus sin A sin B. Sin A sin B. So this will be equals to, you have to substitute A value as 45, B value as 30. B value as 30. So cos of A minus B, that is 45 minus 30, is equals to cos A cos B. Cos A cos B plus sin A sin B. Sin 45 sin 30. Sin 45 sin 30. Okay. So cos 45 is 1 by root 2. Cos 30 is root 3 by 2. Plus sin 45. Sin 45. 1 by root 2 into sin 30. 1 by 2. So this comes to again root 3 by 2 root 2 plus 1 by 2 root 2, which is root 3 plus 1 by 2 root 2. Check that from these two results, we observe that sin 75 root 3 plus 1 by 2 root 2 and cos 15 is also root 3 plus cos 15 equals to root 3 plus 1 by 2. Both are equal. That is sin 75 same as cos 15. Yeah, they are complementary angles. Make a note. And you find what is sin 15 and cos 75. Yeah. Let's find out what is sine 15. Sine 15, that is third division. Sine 15. 15 can be written as sine of 45 minus 30. Now it is sine A minus B form. We have sine of A minus B is equals to sine A cos B minus cos A sine B. Sine A cos B minus cos A sine B. So if I substitute all these known values, if I substitute the values, that is sine A is 45, A is 45 and B is 30. A is 45, B is 30 if I substitute. So sine of 45 minus 30 is equals to sine A sine 45 into cos B is cos 30 minus cos A sine B, cos 45 into sine B is sine 30. Sine 30. So sine 45 is 1 by root 2. Cos 30 is cos 30 is cos 30 is root 3 by 2 minus cos 45 is 1 by root 2 and sine 30 is 1 by 2. So this will come to root 3 by 2 root 2 minus 1 by 2. It's nothing but root 3 minus 1 by 2. That's the value of sine 15. It's the value of sine 15 we get. Next we'll find what is cos 75. Cos 75. Cos 75 can be written as cos of
30 plus 45.
30 plus 45. Okay. 30 plus 45. Just like cos of A plus B, we have the result. Cos A plus B is equals to
Cos A cos B plus sin. Cos A cos B minus
cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B. Now substitute the values. It is cos 30 cos 45 minus sin 30 sin 45. Cos 30 is root 3 by 2. Cos 45 is 1 by 2. Sin 30 is 1 by 2. Sin 45 is 1 by root 2. So this comes to root 3 by 2 root 2 minus 1 by 2 root 2, which is LCM to root 2 again. Root 3 minus 1. So what do we notice from these two bits is sin 15, the result is root 3 minus 1 by 2 root 2, and cos of 75 is also root 3 minus 1 by 2 root 2. So we can say that sin 15 is equals to sin 15 and cos 75 both are equal. Sin 15 and cos 75 equal. 15 and 75 are again complementary angles. Make a note. Next one. If A is equals to 30, comma, B is equals to 60, then find tan A plus tan B by tan A plus tan B by 1 minus tan A tan B. Tan A plus tan B by 1 minus tan A tan B. And what is tan of A plus B? Tan of A plus B. We'll substitute. Okay, first bit is you must find tan A plus tan B by 1 minus tan A tan B. Tan A plus tan B by 1 minus tan A tan B is equals to, yeah, we have the value A is 30, so tan 30 plus tan B is tan 60 by 1 minus tan A tan B, 1 minus tan 30 into tan 60, tan 30 into tan 60. Now, we have tan 30 from the tabular form again. We have values tan 30 and tan 60 values from the tabular form. Okay, what is tan 30 is 1 by root 3. Tan 60 is root 3 by 1 minus tan 30 is 1 by root 3 into tan 60 is root 3. Yeah, which is LCM. If I take it, LCM the numerator is root 3. So 1 plus, yeah, root 3 into root 3, which is 3 again, by, you can cancel this root 3 and root 3, it is 1 minus 1 in denominator. So it is 4 by root 3 by 0, which comes to, yeah, since it is 4 by root 3 by 0, it is 4 by root 0 again, it is infinity. It is infinity. Okay, now, let's check now what is the second bit. Second bit is, it's the value of tan of A plus B. Tan of A plus B, which is tan of, yeah, A is 30, B is 60. So this comes to tan 90 again. Yeah, tan 90 is also infinity. Infinity. So what do we notice from these two is, what do we notice from these two results is, tan A plus B is same as tan of A plus B is same as tan A plus tan B, tan A plus tan B by 1 minus tan A tan B. 1 minus tan A tan B. Similarly, tan of A minus B, you get tan A minus tan B by tan A minus tan B by 1 plus tan A tan B. These are the two important results again. Tan of A plus B is tan A plus tan B by 1 minus tan A tan B. Tan A minus B is tan A minus tan B by 1 plus tan A tan B. Make a note. Yeah. Next, let us take evaluate sine of sorry tan of is tan of 75 degrees, tan of 15 degrees, tan 75 and tan 15. Yeah. How to write tan 75 is?
20 plus 20.
You can write tan 75 as tan of 45 plus 30. 45 plus 30. So it's like tan of A plus B now. 45 plus 30 is 75. So it's like tan of A plus B. Already we have the relation tan A plus B is equals to the result tan A plus B is tan A plus tan B by tan A plus tan B by 1 minus tan A tan B. 1 minus tan A tan B. Which will be, now what is A is 45, B is 30. A is 45, B is 30. So tan of A plus B is tan 45 plus 30 is equals to tan A, that is tan 45 plus tan B is tan 30 by 1 minus tan A tan B, 1 minus tan 45 tan 30. 1 minus tan 45 tan 30. Substitute the values now. We have tan 45 and tan 30 again for the tabular form. Tan 45 is 1 plus tan 30 is 1 by root 3 by 1 minus tan 45 is 1 into 1 by root 3. So this will be LCM is root 3 in the numerator. LCM is root 3 in the numerator, so you get root 3 plus 1 by, again LCM in the denominator is root 3. So you'll get, you multiply the first term with root 3 minus 1. Root 3 and root 3 gets eliminated. This is root 3 plus 1 by root 3 minus 1. Yeah, you multiply and divide by root 3 plus 1. Multiply and divide by root 3 plus 1. Root 3 plus 1 by root 3 minus 1. I am multiplying with root 3 plus 1, dividing by root 3 plus 1. Multiplying with root 3 plus 1 and dividing by root 3 plus 1. This will be a plus root 3 plus 1 into root 3 plus 1 is root 3 plus 1 whole square by denominator is a minus b into a plus b, a square minus b square. Now this is a square root 3 square 3 plus b square is 1 plus 2ab is 2 root 3 by here is root 3 whole square 3 minus 1 square is 1. So 4 plus 2 root 3 by 2. Now 2 is common in the numerator, I take 2 common. So 2 plus root 3 by 2. 2 and 2 is eliminated, 2 plus root 3 is the answer. Therefore, tan of 75 is 2 plus root 3. Must take a note. Now let's find what is tan of 15. Tan of 15, second bit. I can write tan 15 as tan 15 is 45 minus 30 now. 45 minus 30. Then you have to use tan of A minus B, which is tan A minus tan B by 1 plus the other formula we have used. Tan A minus tan B by 1 plus tan A tan B. Again, A is 45, B is 30. Here tan A minus B. Tan A minus tan B by 1 plus tan A tan B. So it will be 1 minus 1 by root 3 by 1 plus 1 by root 3 now. So it will be root 3 minus 1, root 3 minus 1 by root 3 by root 3 plus 1 by root 3. So it is root 3 minus 1 by root 3 plus 1. Root 3 minus 1 by root 3 plus 1 now. Again you multiply and divide by now root 3 minus 1. So root 3 minus 1 by root 3 plus 1. I multiply with root 3 minus 1, divide by root 3 minus 1. Multiplying and dividing by root 3 minus 1. Okay. So this will come to numerator is root 3 minus 1 into root 3 minus 1 is root 3 minus 1 whole square. A plus b into a minus b is root 3 whole square. A square minus b square. So this is root 3 whole square 3 plus b square is 1 minus 2ab is 2 root 3 by square root eliminated 3 minus 1. So this is 4 minus 2 root 3 by 2. I can take 2 common from the numerator. 2 minus root 3 by 2. 2 and 2 is eliminated. Therefore, tan of 15 is 2 minus root 3. 2 minus root 3. Okay? Let's make a note now. Note. Tan 15 will be same as cot 75. Tan 15 and cot 75 both are equal. Because again these two are supplementary angles. Tan 15 is equals to cot 75. Cot 75. Okay. Same way. Tan 75 will be same as its complementary angle cot 15. Tan 75 and cot 15 both will be equal. Okay? Let's solve the question now. If alpha comma beta are complementary angles, alpha and beta are complementary angles, and alpha beta are complementary angles, and sin alpha is equals to 12 by 13. Sin alpha is 12 by 13. Then find sin alpha cos beta minus cos alpha sin beta. Sin alpha cos beta minus cos alpha sin beta. Yeah. Finding sin alpha cos beta minus cos alpha sin beta. Now, see that alpha beta are complementary angles. So alpha plus beta is 90. Alpha plus beta is 90. From here, I can find what is beta. Beta is 90 minus alpha. Beta is 90 minus alpha. Now, let's find what will be cos beta and sin beta. cos beta and sin beta value. What is cos beta?
Sin 90 minus.
Yeah, cos beta will be cos of 90 minus alpha. Cos beta, beta is 90 minus alpha, so cos, substitute beta as 90 minus alpha. Cos 90 minus alpha is sin alpha. So cos beta value is same as sin alpha. Next we'll find what is sin beta. Sin beta is equals to sin of, yeah, beta is 90 minus alpha. So it is sin of 90 minus theta. So sin 90 minus theta, which is cos theta, that is cos alpha. So sin beta is same as cos alpha. Now let's come to this value now, that is sin alpha cos beta minus cos alpha sin beta. It's like sin A cos A minus cos A sin B. Okay, it's like expansion of sin A minus B. But A minus B value is not given. A plus B, alpha plus beta value is given, alpha minus beta is given. So sin alpha into cos beta is same as sin alpha minus cos alpha into, yeah, sin beta is same as cos alpha. So this will become sin square alpha minus cos square alpha. Sin square alpha plus cos square alpha is 1. We have identity sin square theta plus cos square theta is 1. If it is plus here, if it is plus in between, then sin square alpha plus cos square alpha will be 1. If it is plus. But here I have minus sin square alpha minus cos square alpha we have find. We have sin alpha value 12 by 30. Yeah. Or you can find cos alpha separately you can find by using identity. Cos alpha is under root of 1 minus sin square alpha. Because we have sin square alpha plus cos square alpha is 1. So from here cos square alpha will be 1 minus sin square alpha and cos alpha will be root over 1 minus sin square alpha. Okay. So let's find the value of cos alpha beside. Cos alpha is under root of 1 minus sin square alpha. Sin square alpha, square of it, 144 by 169. Now LCM when you take it is 169 minus 144, 25 by 169, which is 5 by 30. So this is the value of cos alpha. Let's substitute back. Let's substitute back this value. So sin alpha, that is sin square alpha, square of it, 144 by 169 minus cos square alpha, square of it, 25 by 169. Just subtract it, you get 119. 119 by 169. Make a note. What's the formula we have entered today? The compound angle sin A plus B, sin A minus B, cos A plus B, cos A minus B, tan A plus B, tan A minus B. And based upon this formula, based upon this 6 formula, you have to solve one problem of your home. Okay. To prove this all 6 formula, you take one problem each, and you have to suppose I give A is equals to 45. B is equal to 30. You have to prove all the six relations taking A equal to 45, B equal to 30. Okay. Assume A45, A30 and verify the formulae related to compound dynamics. That's your home. You must take A45, B30 and verify the results. That's all for today. Check how many are watching our program. This is on three. Okay.
Don't matter what's in your hand. So, it's not just like the basics of it.
Use for your eye. So, course is foundation. Some of class is foundation.